Hello everyone, I welcome you all to Startup Academy. This academy is exclusively for ISS, and we all know that we are preparing for IS 2026. And today we have been covering the topic sampling techniques, and today we will continue with the topic with the new estimator, which is regression estimator. We have till now covered ratio estimator and product estimator in double sampling. Now, today is the topic regression estimator. So, why do we use double sampling? We use double sampling when our auxiliary variable is also unknown. In single sampling, we have two variables, we all know that. One is the study variable, which is y, and the other one is auxiliary variable on which the study variable depend, or study variable and auxiliary variable are correlated. Auxiliary variable provides the information on study variable, and with the help of auxiliary variable, we find the study variable. But here, both auxiliary variable and study variable are not are unknown to us. So we do double sampling. Firstly, we will estimate the study variable, and in the second step, in the second phase, we will estimate the firstly we'll estimate the auxiliary variable, and in the second phase we'll estimate the study variable. These two phases are there in double sampling. So regression estimator in double sampling, right? What do we mean by regression estimator in double sampling? Similar to the regression estimator in single sampling, we denote it by small r and d, which denotes double sampling. And it is defined by y bar plus beta x bar prime minus x bar, where x bar prime is the estimated value of auxiliary variable and beta beta is nothing but the ratio of sxy and sx square. This is the regression estimator in double sampling. Now moving on further, we'll find the estimation and then variance. There are two cases here as well, as we did in the earlier one. Case 1, when beta is known to be beta naught. When this is the case, then what do? We will take estimation of the estimator, which is estimation of y bar plus beta x bar prime minus x bar, which is nothing but estimation of y bar. Now here, estimation of x bar prime and estimation of x bar are both capital X bar, so it will be beta into estimation of x bar prime minus estimation of small x bar. So this will be capital Y bar, and this will be beta into 0, because x bar minus x bar is 0, so it will be capital X bar. So our estimation of estimation of regression estimator in double sampling, mean of regression estimator in double sampling is population mean. Hence, it is an unbiased estimator of population mean. The second one is variance. Variance of mean of regression estimator in double sampling. So we can write it as estimation of mean of regression estimator in double sampling minus population mean whole square. Here this can be written as double sampling, we can write y bar minus beta x bar prime minus x bar minus capital Y bar. And this can be written, if I shift some of the values, this can be written as y bar minus whole square, y bar minus capital Y bar minus beta into x bar prime minus x bar whole square. This can be written, so this is the a minus b whole square. We can write it as estimation of y bar minus capital Y bar whole square plus s beta square into estimation of x bar prime minus x bar whole square minus 2 beta estimation of y bar minus capital Y bar into x bar prime minus x bar. Right? So this is nothing but variance of y. This is nothing but beta square into variance of x bar prime, and this is nothing but minus 2 beta covariance between x bar prime and y bar. So this can be written as 1 upon small n minus 1 upon capital N s x sy square upon y bar square. This is beta square into sx square upon, sorry, it will also contain this n prime minus n sx square upon x bar square, and this is minus 2 beta 1 upon n prime minus 1 upon capital N sxy upon x bar into y bar. So this is the variance of regression estimator in double sampling for beta, when beta, the value of beta is unknown. Now there arises another case, which is case 2. When beta is unknown. We know that we cannot find the values of biasness of mean of regression estimator in double sampling and MSC of mean of regression estimator in double sampling. So for this we use approximation method. So we will consider, let us consider, before considering, let we have been given the regression estimator as y bar plus beta x bar prime minus x bar. Now we will consider, we know that beta is nothing but sxy sx square small. So here we can say that let x bar is equals to 1 plus e1 capital X bar. You can take e1 or epsilon 1, anything. X bar prime is equals to 1 plus e2 capital X bar. Sxy is equals to 1 plus e3 capital Sxy, and Sx square is equals to 1 plus e4 capital Sx square. We will consider this under approximation up to order 2. And we know that estimation of E1, which is estimation of x bar minus capital X bar upon x bar is equals to 0. Similarly, estimation of E2 and estimation of E3, estimation of E4 is equals to 0. Now we will consider the for unbiasedness, or we can say for biasedness. We will check. So for biasness, let us take estimation of mean of regression estimator in double sampling. So it will be nothing but estimation of y bar minus, before taking estimation, let us first solve that only. Mean of regression estimator in double sampling is given by y bar plus s xy upon sx square into x bar prime minus x bar. Now putting the values here, we will be getting y bar plus 1 plus e3 upon 1 plus e4 sxy upon sx square into 1 plus e2 minus 1 plus e1 capital X bar. So estimator y mean of regression estimator in double sampling is given by y bar plus sxy upon sx square will become beta, and x bar will also come this side. We are left with 1 plus e3 into e2 minus e1 into 1 plus e4 raised to the power minus 1. Now we have to take approximation. First we'll expand y bar plus beta x bar into 1 plus e3 e2 minus e1 1 minus e4 plus e4 square minus up to, it goes up to infinity, but we have to take up to order 2. So all of this will be cancelled. So we'll be left with estimator of mean of regression estimator in double sampling is y bar plus beta x bar into e2 minus e1 plus e2 e3 minus e1 e3 into 1 minus e4, which can further be written as y bar plus beta x bar e2 minus e1 plus e2 e3 minus e1 e3 minus e2 e4 minus e1 e4. Rest all the values are not considered because we are taking approximation up till order 2. Okay, so now we will take estimation on both sides. Estimation of mean of regression estimator in double sampling is equals to capital Y bar, because estimation of small y bar is capital Y bar, plus beta x bar into, your estimation of E1 and E2 will be 0. We did this here, E1, E2, E3 and E4, and okay, E1 and E2 will be 0, and we are left with E2, E3, E1, E3, E2, E4, E1, E4. Estimation of E2, E3, estimation of E2, E4, estimation of E1, E3, estimation of E1, E4. Two, four, 1, 3, 1, 4. Okay, this is the term. Now calculating estimation of E2, E3. E2 was E2 was x bar prime and E3 was sxy. So their estimation would be 1 upon n prime minus 1 upon capital N into estimation of x bar prime minus capital X bar into sxy minus capital Sxy. This will be the term, and in the denominator we'll write x bar into sxy. Now there is one formula here which says that mu of AB is nothing but estimation of x bar minus capital X bar raised to the power A and y bar minus capital Y bar raised to the power B. So here we can write this formula, which is nothing but 1 upon n prime minus 1 upon capital N mu, because the power of x is 2 and that of y is 1, because sxy is 1 of x and 1 of y, so x is 2 and that of y is 1, x bar into sxy. Similarly, estimation of E2, E4 would be 1 upon n prime minus 1 upon capital N into mu 30 x bar into sx square. Estimation of E1, E3 would be 1 upon n minus 1 upon capital N mu. E1 and E3 would be 2, 1 upon x bar into sxy. And estimation of E1, E4 would be 1 upon n minus 1 upon capital N into mu 30 upon x bar into sx square. These are the four values. Now we can take estimation of regression estimator in double sampling minus y bar equals to x bar into beta. We will take the values. One upon n prime minus one upon capital N mu 21 x bar into sxy minus 1 upon n prime minus 1 upon capital N into mu 30 upon x bar into sx square minus 1 upon n minus 1 upon capital N mu 2 1 upon x bar into Sxy minus 1 upon n minus 1 upon capital N mu 30 upon x bar Sx square. So all the x bars are common in the denominator, which get cut out with this x bar. And taking the common terms, we will be getting, this will become bias of mean of regression estimator in double sampling, beta 1 upon n prime minus 1 upon capital N mu 2 1 upon Sxy minus 1 upon n minus 1 upon capital N mu 30 upon Sx square. This can further be written as beta 1 upon n prime minus 1 upon n into mu 21 Sxy minus mu 30 Sx square. So this will be the bias where beta is nothing but Sxy upon Sx square. This is the value of bias of mean of regression estimator in double sampling. So this complete today's topic, regression estimator. It's MSc is left. That is a bigger portion that will continue in the next lecture. Till now, I hope that you got what we have done today, and keep on watching videos regularly, along with English and GS as well. And be consistent in your work, so that we'll be able to achieve our goal in 2026 only. All the best. Thank you.